Hello and welcome back. Today we're talking about factors of whole numbers. Positive whole numbers, in fact. So what are factors? It would be better if I showed you an example. If we have a number such as 24, actually, let's change that to 36. Then a factor of 36 will be a number that you can divide 36 by that will not give you an answer with a remainder. So in this case, if we have 36 and divide by 2, we get 18. And there's no remainder. This also means that 36 divided by 18 would be 2 without a remainder. This means that both 2 and 18 are factors of 36. Now, factors tend to come in pairs. So for instance, if I divide 36 by 4, I get the answer 9 as my quotient, meaning that both 4 and 9 are factors of 36. You can see that since 4 times 9 is 36. Now, what about 36 divided by 6? Well, the quotient would be 6 without a remainder, meaning that 6 will be a factor of 36. But it appears twice in this equation. Here and here. Because we are concerned with unique factors, we only include 6 one time in our list. If we continue, 36 divided by 3 is 12. Meaning that 3 and 12 are factors of 36. And of course, we know that if we divide 36 by itself, we would get 1. Meaning that 1 and 36 are also factors of 36 itself. Oops. Now, a useful way of listing these factors is from smallest to largest, Let's write them down in pairs. So here's what I mean. Write down that the factors of 36 are 1 and 36. And to keep these pairs organized, we can link them with an arc like this. 2 and 18. 3 and 12. 4 and 9. And 6. Yes. Another way to write down factors of a number would be to use a factor tree. So let's try with 36 right now. If we start with 36, we know that 9 and 4 are factors. We wrote that up above. There's just one pair of factors we can use. We can also use 3 and 12, or 6 and 6. If I write down the factors of 9 and 4, we could write it as 3 and 3 for 9, and 2 and 2 for 4. But instead, let's write it as 1 and 4 this time. Now I could continuously write down 1 and 4, but as you see, this tree does not get any simpler by doing this. Instead, we can write it out as the factors that are prime numbers, which are 2 and 2. Let's look at this other tree. 3 we know is already a prime number, so we can leave this as is. And for 12, we can write a pair of factors. Let's say 2 and 6. The factors of 6 are 3 and 2. And we can use the breakdown of 6 in our other tree here. Generally, when constructing a factored tree, you stop once all the factors at the lowest level of your tree are prime numbers. You achieve that in each of these trees. So, we multiply the lowest levels of these factors together. On this first tree, we have 1 times 1 times 3 times 3. times 2 times 2. And we know that this equals 36. Because 1 times 1 is 1, multiplied by 3 again, by 2 and by 2 again. So now I have 3 times 3 times 2 times 2. And then we have 9 times 4, which is 36. If we look at the second tree, we have 3 times 2 times 3 times 2, which is mathematically equivalent because 1 times a number is that number. So 2 ones from the first tree could just be omitted. And this third tree, we have the same thing. In a slightly different order. So 3 times 2 times 2 times 3, which equals 36. So as you can see, if you write a factor tree all the way down to the point where you only have prime factors, it will be the same. Typically, when writing out only the multiplication of prime factors, we write in numerical order. So we have 2 times 2 times 3 times 3. And it can often be expressed as exponents, well, in terms of exponents. So we have 2 squared, because we have 2 2's, 1, 2, multiplied by 3 squared, again, because we have 2 3's, 1, 2, which again will equal 36. This is called the prime factorization, where you write a number as multiplication of only prime numbers. Now, I earlier said you could write or determine the factors of a number this way. How do we do this? Well, let's take a look at the prime factorization of 36. So 36 equals 2 times 2 times 3 times 3. Grouping these numbers such that we end up with 2 groups will mean we have 2 factors. So here's what I'm saying. I could say, because of the associative property of multiplication, I can say that 2 times 2 times 3 times 3 will be the same as 2 times 2 in parentheses, multiplied by 3 times 3 in parentheses, or 2 times 2 times 3 in parentheses times 3, or 2 times, in parentheses, 2 times 3 times 3, and so on. If we write this out and evaluate the expressions in the parentheses, we have 4 times 9. This is a pair of factors we saw before, which is equal to 12 times 3. Another pair of factors that you saw before, which is also equal to 2 times 18. Another pair of factors you saw before. We can continue doing this or adding a multiplication of 1 to figure out all of the factors of 36. Thank you for joining me today as we covered factors of whole numbers, positive whole numbers specifically, and prime factorization. Hope to see you next time. Please like and subscribe.